All right, let's hop back here. This, I guess I get these guys. CD. Okay. Cool beans. Share the screen. About to broadcast. Okay. All right. Greetings, YouTube. Greetings, scholars. All right. So we are at the top of week 6. Right? It's Monday, right? So hopefully you all had a great weekend. You got some rest, you got some play, but you also did the work that you needed to do. I definitely encourage balance between work, life, play. I think that's already passed. Okay, so our rhythm from here going forward, throughout the end of the semester is basically we do 3 weeks of lecture, so 3 weeks of new material. On that 4th week, every multiple of 4, we're going to have an exam, right? So if this is week 6. That means during week 8, we're going to have exam 2 covering the materials from weeks 5, 6, and 7, right? So we're just going to kind of continue where we left off. I can't think of any real announcements. Top of the week, hopefully got our work done. The main thing is we're just making our way through our assignments. On Pearson, you can get ahead if you can. Idealistically, you want to try to go ahead and finish that homework and quizzes as soon as possible, so that way you're only waiting on the exams, and then the lectures are there. So all the stuff I want to say live is already pre-recorded. I've just been kind of going through. I just been doing the lectures live and the homework, just trying to fill the air. But if you guys, this is remote asynchronous. So as long as you've gotten into my Zoom, that means you've gotten your attendance credit. You're not obligated to stay. And the real intent is for this time to be like a Q&A study session or office hours, right? So, I expect you to watch the lectures on your own, take notes if you're in class. We'll do what we can in class together, but obviously we're only together for 50 minutes. 10 of those minutes is checking in and logging in and stuff like that. And, so, you just want to maximize your time when we're apart, so that way we can be efficient with that time when we're together. As usual, if you have questions, feel free to unmute yourself to get my attention. That's the best way. Or you can type in the chat. I do check the chat periodically. Otherwise, we're going to kind of continue where we left off. We were discussing chapter 3 last time. I forget what this section that was. But this time we're going to be working on rules of logarithms. All right. So I'm sure we talked about exponential functions. So we're going to consider rules of logarithms, where the log is basically the inverse of the exponential, just like addition is the inverse of subtraction, division is the inverse of multiplication. So, when you have a function, the inverse undoes that function, right? And so that's what logs do for exponents. And so a lot of the properties that we have for exponents, it's kind of like the reverse is true for logs, right? So typically something switches. Okay, so section 3.3, and I'll check attendance again in about 3 minutes. I usually like to check it again at the 15-minute mark. So that's in about 2 minutes and 40 seconds. So section 3.3, rules on logarithms. A few objectives. We like to learn the rules of logarithms, estimate a large number, change the base of a log, and apply logarithms in growth and decay. So we have some rules of logarithms. Let m, n, and a be positive real numbers with a not equal to 1, and let r be any real number. Let me give myself a little bit of space here. Go like this. So first we have this product rule, right? The simple way that I remember this, I don't know if it's simple or not, but the simplest way that I have so far, the log of the product is the sum of the logs. Let's look at that one more time. The log of the product is the same as the sum of the logs, right? So m, n, and a are positive real numbers where a is not 1. So these are positive real numbers and this can't be 1. The log of the product is the sum of the logs. The log of the products of 2 or more numbers is the sum of the logs of the numbers, right? So the log of the product is, so this is the product rule, right? You're taking a log of a product, you can essentially break it apart into the sum of 2 logs. So then we have the quotient rule. The log of the quotient, same initial conditions. The log of the quotient is the difference of the logs. All right. The log of the quotient of two or more numbers is the difference of the logs of those numbers. And then the power rule. The log of the power is the power times the log. The log of a number to the power of r is r times the log of the number, right? So those are the three main rules: the product rule, quotient rule, and power rule. The log of the product is the sum of the logs. The log of the quotient is the difference of the logs. The log of the power is the power times the log, okay? Okay, so those are just some rules or properties that we have, and then let's see if we can see them in action. So given that the log base 5 of z is 3, the log base 5 of y is 2, we're asked to evaluate each of these expressions. I think I would like to take some notes here. Let me check Zoom one more time. I know we were 30 seconds early, but that is a-okay. Let's see what we're looking like. Okay, cool. It looks good. Chat looks good. Okay. So let me give myself some. I'm gonna add a page. Come on. And I would like to get a copy of this. We're taking it basically. I could take it from here, I guess. No. So we're gonna take that and drop it right here. And I'm pretty much just using this for a reference as we work through the different parts. Okay. So just to kind of reiterate, so we're given that the log base 5 of z equals 3. We're also given that the log base 5 of y equals 2. So then for part A, we're asked to evaluate the log base 5 of y times z. And let me write it similar to how it's shown, y times z. Okay, so the first rule that we reviewed or introduced was the product rule. The sum of the logs, the product of the logs is the sum of the logs, right? So we can break this apart into log base 5 of y plus log base 5 of z. So then that's going to be 3 plus 2 is 5. Okay. And again, if anything isn't clear, feel free to unmute yourself to get my attention. Let me copy this. Okay. Let's do the next one, part B. So we have log base 5 of 125y to the power of 7, like this. Okay. And let's try to clean this up just a little bit, because I see that my 7s and my z's look a little bit similar. Okay. So this one looks like it has two properties in once: the product rule and the power rule, right?
Wait, Professor?
Yes.
Can you explain letter A for me real quick?
Okay. So, we just had those 3 rules: the product, quotient, and power rule. So this is an application of that first rule, the log of the product. So we can break this apart into the log of y plus the log of z. And then the instructions gave us that the log of y is 2, the log of z is 3. So then it gives us 5.
So it's just substitution in a way.
It's application. It's not really substitution. That one kind of is, I guess, but it's really what it is. It's an application of this guy, the product rule.
Oh, okay.
And so the next one that we're doing is the product rule along with the power rule. All right, let's see it. So for part B, okay, so we can break this apart. If we apply the product rule, this is going to be log base 5 of 125 plus log base 5 of y to the power of 7. All right. Okay, any suggestions? Now, how can we manipulate these guys or apply a rule so that we can use what was given?
We can use the product rule, the first rule from letter A.
Okay, yeah, we did that once, right? And that's how we split it apart. So then, what do you think we can do with this guy? Namely, this guy. All right, so let's see. Let's try log base 5. 125, is that a perfect power? Like something to some power, right? I think 125 is 5 to the power of 3. Okay. So let's leave that one. And then the other one, right here. I think we just said that the power rule, the log of a power. So whenever you take the log of a power, essentially, you can just bring that power down. Okay. So then that's going to become 7 times the log base 5 of y. Okay, so we're almost done with that one. And then we can also apply the power rule here as well. Okay, so if we keep going, we're going to have 3 log base 5 of 5 plus 7 times the log base 5 of y. Now, I think last time we said something to the effect, log base 5 of 5, this part right here, this thing goes to 1. So log base 5 of 5 is 1. Okay. And if we apply what was given, we'll get the following. 3, that's a 1. So, we're good there. 7. Now the log base 5 of y we were given, that's a 2. Okay. And for me to just be consistent, I really should switch these around. Yeah. Okay. So then if we finish out the one that we're on, was at 14. So 3 plus 14 is 17. Let's actually, can we just paste? Okay. So that one, what were two rules in one goes, the product rule with the power rule. And I want to say last time we said that the log base 5 of 5, that was a property of logs, is 1. I think that's something from last time. Okay, let's try part C. I really want to do that, but I'm totally being lazy. Let's try part C. So part C says log base 5 of the square root of z divided by y. So we got z divided by y, we got the square root of that, and we're doing log base 5 of that. Okay, any suggestions? All right, so remember we have the product rule. The log of the product is the sum of the logs. The quotient rule, which is the log of the quotient, is the difference of the logs. And the power rule, which is the log of the power, is the power times the log. So does anybody see how we can apply one of those rules to this guy in part C? Any kind of manipulations? All right, so square root. What's square root as a rational expression, as a rational exponent? Square root is the same as that radicand to what? I almost gave it away. Square root, right? How can we rewrite square root? What's another way that we can rewrite square root?
Power to a half.
Power to a half, right? So all of this stays the same for now. Square root is the same as, let's do it like this, to the power of a half. So then what rule do you think we can apply at this point? Product, quotient, or power? Right? I think it's pretty clear. The power rule, we have the log of a power, so that power can come down in front. So then this becomes 1/2 log base 5 of z divided by y. So then, I don't want to I haven't got to that state, that level of picking on people. I haven't gotten there yet. Because if I pick on you and if you're a no-show, I still don't feel like I should take your attendance, but I'm totally being lazy in things. But here, right, the quotient rule, and I'm trying to encourage you to talk because whoever does the most talking does the most learning in this context. If I'm doing all the talking and you're just sitting passively by, it's not going to get through. You have to engage. You have to speak. Like that's the only way. I mean, you can do it on your own. You don't necessarily have to talk during class, but it makes me feel somewhat better as long as I know at least a few people are getting that. But the quotient rule, right? So the log of the quotient is the difference of the logs. All right, because I can do this. I do this stuff if I sleep. I remember when I was in grad school, I was dreaming. I was literally doing stuff in my dreams, and I would wake up and I was like, dang, that was true. I would be speaking Spanish and everything. I'm like, it's movie local, but it's that bien. Anyway, so log base 5 of z minus log base 5 of y. That's what I was kind of sharing with my students earlier. What it really takes to be proficient at this stuff, it honestly takes like about 3 to 4 hours every day. Whatever we practice, we get really good at, right? And those aren't my own words. I'm borrowing that from a YouTube video from the past. But yeah, so whatever we practice, we get really good at. Thank you, man. Time just flies. Let's see. Oh, I know. I saw that one. Oh, okay. All right. So we said the log base 5 of z. Z was 3 and y was 2. So then this was going to be 1/2 3 minus 2, which is 1/2. All right. Okay. And then for D, okay, I think that one is correct. Z to the 130. Okay, I might have to go back and forth a little bit. Log base 5, z to the power of 1 over 30 becomes y to the power of 5. All right, let's give this one a go. All right. So, anybody want to take a guess at which rule we apply first? Once. So
is it the exponent rule?
Not the power one. That one is actually coming up before that one.
The product rule.
Product rule, right? So the product rule is what? The log of the product is the sum of the logs. So this is going to be log base 5 of z to the 1 over 30 plus log base 5 of y to the 5th. So now if we apply the power rule, what happens? We apply the power rule, what happens? So when we take the log of a power, we can bring those powers in front of the log. The log of the power is the power times the log, right? And I keep saying it like that because it does have its own rhythm and frequency. And so even though we're not in a testing environment right now, that doesn't mean you won't ever be. And so that constant, like when you're saying it, that repeating it like that, it has a rhythm and it's like a package deal, right? But the only way it kind of gets in there is through repetition. Okay, let's keep going. So then this is 1 by 30. I think the z was 3, right? So I'm just going to go ahead and put my 3 there. Plus 5. And the y was 2. So then, long story short, that becomes 1 over 10 plus 10. I think I'm just going to write it as 10.1. Okay. All right, let's see, how do we do? Let's see. So we got, and also all the stuff that you see me writing, I made a PDF version of everything is available on our Blackboard page, all the way from the beginning of the semester and at the end of each session. I load a PDF, I make it accessible. So all the stuff you see me writing, you're gonna get a copy of it. And you already have a copy of everything from the past, from the beginning. If you go to our Blackboard, it's gonna be a page that says daily lecture notes box link. You click on that, it's gonna open. You might have to install the Box app, and it's in there. It's in the notes folder inside of that link. It should be fairly simple to find. We got 5, 17, 1/2, and 10.1 or 10 and a 10. Let's see how do we do. So there's the 5, 17, 1/2, and 10.1. Okay. Yeah, we blink our eye and everything is over. Okay. Anybody feel like they can give this a go? These are not. I feel like if this is an introduction, it's doable, but you know, I wouldn't judge you if you didn't feel comfortable doing it, because it's not so straightforward. Let's skip to the group. Let me start with the first one. So then for part A, we have log, out of space, log base 2. On top we have x squared, x minus 1 cubed over 2x plus 1 quantity to the power of 4. Okay. Let me go ahead and get a copy of B log base C square root x cubed y squared z to the 5th. Okay. I'll come back and get that in just a moment. Okay. So looking at something like this for part A, let me see the instructions. Asks us to write these in expanded form, right? They're asking us to expand these. So what do you think is the first rule that we apply? Are we going to do the product rule first, the quotient rule, or the power rule? If you had to guess, which one do you think we apply first? So you have this is like the main grouping symbol, right? The division. So we're going to apply the quotient. Okay. So if we apply the quotient, basically it's going to be the log of the top minus the log of the bottom. All right. So I think I might need to drop down to the next line. So we're going to say the log of the top minus the log of the bottom. Log base 2 of x squared times x minus 1 cubed. All right. That's the log of the top minus the log of the bottom, 2x plus 1 to the 4. Okay. All right, so we split it based on the main grouping symbol. So now if we focus on this guy by itself first, what rule can we apply? What rule do you think we apply next? All right. And you can kind of do these in one go, but I think just for instruction purposes, I'm trying to break it apart. You know, the main grouping symbol here is multiplication. You got this guy times this guy. So then the product rule basically, right? So then it's going to be log base 2 of x squared plus log base 2 of x minus 1 cubed minus, okay. What about this guy? Can we break this apart? I hope you're not thinking yes, because the yes would be wrong, right? We have a product rule, but we don't have a sum rule. So when we have a product, we can break that apart into a sum. But when you have the log of a sum, you can't break that apart, right? So this guy is going to stay as is. But we can apply the power rule, okay? So another thing I kind of want you guys to be aware of, this is the lab, right? This is the lab. This isn't like life or death. I know it's nobody really wants to be wrong, but you're only wrong for a moment. And then you discover something else, you change your mind, and then you're not wrong anymore. But that's how we learn. That's how we're built as humans, right? There's no rule that says you're allowed 3 mistakes and then that's it, right? That's not human. The humans, the life of a human, we're allowed as many mistakes until we get it right, right? So you got to get over that fear of being wrong, because it's okay. Like that's the only way that you can, get to the root of it. You have to bump up with that sensation of being wrong momentarily, and then when you learn something different, you do different. But it's okay. The 4 comes down log base 2 of this guy. All right. Okay, and then I think if we apply the power rule again from the beginning, this guy and this guy. Okay. So then we get 2 log base 2 of x plus 3 log base 2 of x minus 1 minus 4 log base 2 of 2x plus 1. What time is it? We got a solid 10 minutes. Okay. So this is where we ended. So that's going to take a little bit of practice. Hopefully you all are working together. I encourage it. Hopefully you sought out the tutors and you know how to connect with the tutors. You either have their contact info or you know their schedule. You have support. You have to ask for it. You have to use it, right? You just have to speak up. I'm here. I'm here. All right, we're all here trying to encourage you. Because this is still the safe space, in these hollow crowds of the house. Because you get out in the world, the only way you really get proficient, you have to be in that ignorant phase, right? It's just a matter of how soon can you get past it, right? If you wait until the last minute and then it's a dire moment and that's your first time seeing something, then you're not gonna have the awareness that you need when you need it. Versus, you go ahead and get past it now, then when you do need it, it's already a part of your psyche. Write each expression in expanded form. So part A, I forgot about B, right? Oh, that was only part A. All right, so let's go ahead and try part B. So I know I have a copy of it. And I'm tempted to have you guys do this. If we were in class, I would have you guys come to the board for this. And I know I could do like a whiteboard. I know Zoom has that. But I'm working on a tablet, right? Because I know everybody doesn't have a tablet, to be able to write. And it can be kind of bulky trying to go back and forth to show you guys work. Right. So we saw one that was similar to this, where what did we do last time when we had this guy? What did we do last time?
Did the power of a half.
Right. So square root, we were able to rewrite it as the power of a half. Okay, so then we had log base C. So we rewrite in the square root to the power of 1/2. Okay. So I think we also apply the power rule. So that means that 1/2 can come down. So then we get the 1/2 and then everything else stays the same. Log base C. We got this x cubed, y squared, and z to the 5th. All right. So then what rule do you think we apply here? Right. So we did the power rule for the first one. So this was the product rule, right? We got something times something times something. So then let's apply the product rule. All right. So then we got the 1/2. So we can expand it. Log base C of x cubed plus log base C of y squared plus log base C of z to the 5th power. Okay. And then one final step. Let's try to get one more example before we let out for class. Let me see. Yeah, let's try to get at least one more, maybe 2. All right. So then the final step here, 1/2. Now you could distribute that 1/2. Let's go ahead and distribute the 1/2 as well. So if we bring those powers down and distribute the half, that might be a little bit extra. Let me hold off on that. It's the same thing. It's just how you want to express the final answer. 3 log base c of x plus 2 log base c of y plus 5 log base c of z. Now, the same way, in a similar manner where we expanded these, oops, I wanted a copy of this guy. Copy, paste. So in a similar fashion where we expanded these laws, we can actually work backwards and, you know, condense the law, right? So if it's expressed in a certain fashion, you can undo it. Okay, let's see, for part A, I think that's what we got. 2, 3 minus 4. Yeah, I'm gonna leave that one. Okay, so they did distribute the half. So we ended up stopping here, and they just took it one step further by distributing the 1/2. Okay, so that's fine. So then I might do this one a little bit quickly. So we saw in the previous example where we expanded a log. So now we're going to be starting with those answers and working in reverse and condensing the log back into the original form, right? So if we look at the first one, the main grouping symbol is the minus. So that's the tail end of the quotient rule. So if you work backwards, that means we can condense this into a quotient. So this should be the log of 3x divided by 4y. And I just essentially started with the answer from the previous and applied the quotient rule in reverse. Okay. So here the main grouping symbol is this plus. Again, this guy does not condense. The plus inside the log just stays as is. And we also have these coefficients that can move to the power. Right. So kind of want to do it in one go. I know we have an x squared, right? Because this 2 can go up and this 1/2 can go up. So when that 2 goes up, that's going to give us an x squared. When the half goes up, that's going to give us square root. And I think we're just taking a natural log of all of this. Okay. Let's see. I might need some more space, but the 2 can go up. Okay. Let's see. So that's going to be a 25. Is that right? That looks right. It looks like it's 25 times 9. So 225. So it looks like we have 225 on top. And on bottom, we have 75. Hey Siri, what's 225 divided by 75?
225 divided by 75 is 3.
3, right? Okay. So we have log base 2 of this. Ultimately, that's going to be log base 2 of 3. So again, I went a little bit quick because we're out of time. I got time for this last part, and then that's it. Okay. Okay. So we got that counterpart. We're going to highlight in just a moment. I probably should give myself some space for this one. Yeah, let me just give myself some space. All right, so we have 1/3, right? Let's see. So when I look at these two, I want to multiply them and then say divided by this guy, right? So honestly, I see it now. Yeah, I'm just gonna write the result. So right here, these first two end up being multiplied. So that's gonna be x times x plus 1. Okay. If we're condensing, so it looks like we're going to have x squared plus x divided by x squared plus 1. And then with that 1/3 going to the power, it's going to become, so to the power of 1/3 is the same as cube root. And then we're taking the natural log of all of that. Okay. I know that was a little bit rushed. Even though if I were to write out all the parts, it's not that much different. Let me, can I paste? Okay, that's fine. I can use this. So for the first one, we got this. Second one, we're here. The third one, we are here. And the fourth one. But again, the idea here is that we're starting with the answers from the previous case and then working backwards, right? We're basically applying these rules in reverse. 3x over 4y, x squared times the square root of x squared plus 1, log of 3, cube root x squared plus x over x squared plus 1. Okay, that looks good. That looks good. Log of 3, thank you. And cube roots. Okay, so they did not distribute. I distributed that x, but they didn't. It's the same thing. All right, cube root of that. Okay. I feel like there should be questions, but because of like material like this is why I encourage you guys to work together. Usually it just gives students a hard time. I can imagine being remote, it just makes it worse, right? But I can assure you that if you were in my presence, even when the students are in my presence, they still just this feeling of like, oh my God, what is this, right? And it's not that it's I guess maybe it is impractical. It has its applications, and it's in everything that we use and that we do. We're just not aware of it, right? This kind of stuff. But it's used in a lot of like modeling and like systems. So whenever we're like, using technology to create like a model of something or replicate something or simulate something, or like certain buildings and systems and economics and rates and rhythms and, building the houses and building our devices and traveling. And I'm telling you, this stuff is all up in there. But everybody is not a producer. And the thing that's so strange is like our culture, I feel like as a collective, we don't encourage creativity, right? But this is like the precursor to creativity. When you look at like Iron Man and these people building like Iron Man suits and like, I don't know if you saw the video where in the past the guy had a jetpack like Buzz Lightyear or Iron Man. Apparently that jetpack, not the one that did not the Buzz Lightyear style, but the Iron Man style. Apparently that suit is now available for commercial purchase. Like as a consumer, we can actually go and buy one of those Iron Man suits. It's kind of bulky, but it's a jetpack and the guy was hovering. And it makes sense as far as the design. When I look at it, it makes sense as far as how it works. But the construction of this kind of stuff is the underlying language to the construction of that, right? And again, if you're not like an engineer or a programmer or something like that, just do the best you can to get through it. If it were up to me, I would not have you guys be taking this. I would just save this for whoever needs it. But, this is where we are, so you just have to do the best you can. Yeah, that's what it is for right now. Are there any questions before we go our separate ways? Going once, going twice. Let me go ahead and load a copy of these notes. So all the stuff that you saw me writing, I'm going to make a copy available to you right now. So this is the fall. This is College Algebra 2. To the notes, updated notes, right? So this is week 6. 4 was the exam. Yeah, we're good to go. Export there. It's in the box. So when this bar finishes loading, you'll get a copy of everything that you saw me writing. We made it about halfway. So on Wednesday, we'll see like, okay, we can either continue where we left off in the notes and continue with this lecture, or we can work through homework questions on Wednesday, right? So maybe I'll make a poll or something. I'll poll the audience to see what you guys would like to do. If there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, stay dangerous. Peace. Right.